Now, our next speaker, Dr. Nguyen, is he's leading our lab at OUCRU in Ho Chi Minh City in Vietnam, and she has been the first to implement in-country amplicon sequencing for spot malaria, and on top of that, she regularly performs other analysis and studies of genetic epidemiology of malaria. So without further ado, I'll let her talk.
Good morning again, everyone. Actually, I and OUCRU team, and together with the Vietnam National Malaria Control Program, Dr. Quang, Dr. Thắng here, and also joined Oliver in the GenRe-Mekong project for the last 7 years. But today my talk is not about genetic epidemiology of Vietnam. I want to mention about the different things that instead of using only the genetic surveillance, we also have different way to integrate method to monitoring the drug resistance more efficiently. I think everyone in the room and online now also understand about the progression of drug resistance in GMS. And I think Lauren has just shared with us about the beautiful talk about drug resistance this morning. And also Paranya has shared about the genetic epidemiology in GMS region. So I just want to highlight here together with the progression of the drug resistance, especially with artemisinin and its partner drugs, piperacin in the region, I would like to highlight that. Together with this, actually there's many development to identify clinical markers, molecular markers, the in vitro markers related to artemisinin and piperacin resistance. So also during that time, also track 1 and track 2 multi-country trial has also been conducted. It showed us that to answer the question related to solving the drug resistance problem in the region, there's many ways. Many institutions and research groups join and develop many methods. And the idea is how instead of using each of them, we use all of them to monitor the drug resistance more efficient. And I thought everyone in this room has played puzzle in your childhood. And today I will talk about the 3-piece puzzle. And for the puzzle, it is the combination of each piece to make the beautiful pictures. And for the approach we use for monitoring the drug resistance, it will be the same. And the importance I want to mention here is the piece should be put in the right position. Then it will make the beautiful pictures, but if it was placed wrongly, then the outcome will be not like what we expected. And for the puzzle today, for effective monitoring the drug resistance, then there's many tools, especially 3 highlight tools. The first is using the genetics marker. The other is in vivo trial or the TES that National Malaria Control Program usually used to measuring the drug efficacy. Lastly, using the parasite itself for ex vivo and in vitro assay. And each of the tools has also developed and has the very standard procedure. For genetics marker, in the last 7 years, I think GenRe-Mekong projects have done the very beautiful and developed a very beautiful procedures from collecting the private spot sample from the site from many countries, go to the high throughput amplicon sequencing, then generate the sequence and generate the data report and back to the National Malaria Control Program, like Varanya has talked previously. For the second part, for the in vitro trial and TES, mostly it targets to the patient and using the standard protocol of WHO, and it has many measuring from the clinical trial to assess the efficacy of the drugs, but mostly it will be the treatment successful or treatment failure rate. And for this piece, I think the National Malaria Control people here who are in very best place to put that puzzle into the pictures. So I don't mention much about the in vitro trial result in my talk. And lastly, using the parasite itself, we can measuring the exposure of parasite to the drugs in vitro to understand its self-resistant to the drugs. And so far, we can use the WHO schizo-maturation assay to measuring the drug sensitivity to several drugs, and especially in recent years, the development of RSA and the PSA assay to measuring the drug sensitivity to artemisinin and piperacin. And for those drugs, and as I mentioned earlier, usually the result was present at the treatment failure rate together with the clinical markers like the day 3 positive, the parasite clearance half-life, and also the proportion of parasite clearance time. For the genetics, using genetics marker, the result should be the proportion of the markers related to drug resistance and also generating the epidemiology map, like Varanya has shown previously. And for the in vitro ex vivo assay, it should be the IC50 of the parasite and also the survival rate of the parasite when it was exposed to the artemisinin or piperacin to understand the proportion of drug resistance from the view of in vitro and ex vivo assay. Each method also have their advantages and drawbacks. I would like to mention a bit about the advantages. Firstly, for the in vitro trial, it is the gold standard for measuring the clinical efficacy, and it does not require any technical expertise, also special equipment or reagent, and it follows the WHO standard protocol available, and mostly it guides the treatment policy. And for the genetics marker, I think the strongest of this is how to detect the resistance before it becomes clinical evidence. And it's really suitable for surveillance purpose. And like in vitro, it doesn't being affected by the host compounding factors, immunity, and the drug's pharmacokinetics. And for genetics, it is easy to collect the sample, store it, and transport by collect the blood sample using the filter paper. And for the in vitro ex vivo assay, it also valuable for investigating the drugs candidate and characterize the drug resistance. They also have several disadvantages. For example, the in vivo trial, they will miss classification of the recurrent parasite and has the effect of the patient immunity and drug PK on the outcome. And also it needs the correction from genotyping to define the final outcome. And for the other tools, genetics and in vitro, it not always correlate with the in vivo result. And it's required a high technically and expertise, and also there's a lack of some standardization. However, using those and integrated tools will support us to monitoring the drugs resistance more efficiently. Why? Because actually those methods has the association between their outcome. It is several examples. We can observe the association between the parasite clearance half-life, it is the clinical markers, together with the K mutation. It is you will observe the association between the in vivo and the genetics. And also we observe that for the case that carry the C5ADY parasite, it's also the parasite will have the high survival rate when it was exposed to the DHA in vitro. And other, for the case that was treatment failure, that also carry has the higher survival rate when the parasite was exposed to the DHA. And another example is the association between the treatment efficacy and plasmid gene amplification and the parasite survival rate when it was exposed to piperacin in vitro. You will observe here it is the several data from the early period that we observed that in 2015, the case with defined treatment failure the parasite will carry the multi-copy of the plasmid 2 gene. And also for those parasites with the treatment failure, the survival rate of the parasite when exposed to piperacin in vitro is really high. And just back to the story, the fact that many countries have changed their drug policy to deal with the drug resistance, and observed from the data that Varanya has shown related to the rapid declining of piperacin resistant parasite in Vietnam after the drug policies has been changed. We can see that the transition of drug policies is very good choice to deal with the drug resistance. And after changing the drug resistance, then the question is how to monitoring the new applied treatment. And especially for Vietnam, we use the artesunate pyronidine, and also for Laos, currently the partner drugs is lumefantrine, and also Cambodia, they have several treatments for the country. And we want to integrate the data from the in vitro to add in the information together with the in vivo trial and genetics to provide more information about the drug resistance. Actually, there's no available markers for lumefantrine, pyronidine, but we can do it. We can expose the parasite to those drugs in vitro. That's why we can answer the question about the drug resistance, the drug sensitivity to the drugs that have no available molecular markers, and also cannot assessment the efficacy itself when the currently first line treatment is combination between artemisinin and other partner drugs. I'll give you an example of drug resistant profile of Quansiverum isolate in vitro. Actually, the parasite was exposed to the serial dilution of drugs concentration, and we measure the IC50. It is the concentration that inhibits 50% of the parasite development. And the measure is the parasite is exposed to drugs, the parasite count then have been done, then we calculate the IC50. And from this drug resistant profile, we can calculate the IC50 value of the parasite to each drug. And from the data showing over there, we can say that for this sample, it is sensitive to amodiaquine, resistant to chloroquine, sensitive to quinine, sensitive to mepropin, sensitive to lumefantrine, sensitive to pyronidine. And for the DHA and piperacin, we use the RSA and PSA assay to measure not the IC50, but the survival rate of the parasite. And comparing to the cutoff, you can see the cutoff is the green line on figure, that we can conclude that the parasite is sensitive or resistant to the drugs. And for this isolate, the parasite is resistant to both DHA and piperacin. It is just the profile of one sample. And if you do with several samples and more samples, you have a bigger pictures of the parasite resistant profile of a sentinel site, a province or region, you can do for the country. But it requires the very strict inclusion of the sample before the in vitro testing. Here is, I give you some example of several falciparum isolate the parasite sensitivity to lumefantrine, and observe from our data. Actually, we do comparing the IC50 of the field isolate together with the IC50 of the reference lab strain like DD7 or DD2, and comparing to the cutoff value. All of the cutoff value we use for all the drugs in vitro is based on the WHO guideline. Then we can say that the parasites here is still sensitive to lumefantrine. And another data here is about the sensitivity of the Plasmodium falciparum isolate to pyronaridine. And we also do the same. We calculate the IC50, collect with the cutoff value, and the parasite here is also 100% sensitive to pyronaridine. And I hope with the recent two slides that can have the NMCP here to have more pictures about the drug resistance of the parasite to lumefantrine and pyronaridine. It is the current partner drugs used in the current ECT. And the question is how about the sensitivity of falciparum to other drugs? And we do test with the amodiaquine and quinine, and also the parasite is still sensitive to those drugs. And for mefloquine and chloroquine would have the available molecular markers, then we observe that 100%, almost 100% of the parasite is resistant to chloroquine, and it's quite correlated with the data from genetic surveillance, and also from mefloquine. Several parasites is considered resistant to mefloquine. That's why we suggest that we will monitoring the parasite population more closely to understand more about the mefloquine, because from genetic surveillance, almost of the parasite is still sensitive to the mefloquine. That's why we keep suggesting the combination with mefloquine is still used as rescue treatment. But almost of the parasite from the in vitro also are sensitive with mefloquine, but there's few strains. Then we need to do closely monitoring of this. And moreover, we think that integrating data from different methods will provide a better understanding of the drug resistance. It is the artemisinin resistance in Vietnam in several sentinel sites. This is the result from genetic surveillance, and it is the result from the in vitro. And when you have the data from IC50 from the in vitro test based on IC50 or survival rate, you can categorize the parasite sensitive or the resistant. And with this data, it is easily to map if you collect the sample from different sentinel sites using the current tool that Oliver and the GenRe-Mekong team has developed for mapping the genetics data. And also for the paraffin resistance, we observed that from the in vitro data, then some of the site the resistance is declining, and for the other side, the parasites return to sensitive to paraffin in the recent year. And I think one more thing I would like to mention here, that in vitro and ex vivo assay not only apply for falciparum sample, but we can do it with vivax isolate. And actually, there are very few markers of drug resistance to vivax, and I think the piece of puzzle related to genetics marker related to vivax will be filled this afternoon with Shara talk, actually because she's a queen of vivax. And we want to show here the example of drug-resistant profile of Vivax isolate. And we do test the Vivax isolate is a sample, the actual sample from the site with several drugs that you saw in the screen, that ammoniaquine, artesunate. I mean, we test with own drugs we have. Then so far, the profile of drug resistance is the Vivax isolate is still sensitive with own drugs. And but actually we cannot culture the Vivax, but we can do the drug test with the Vivax isolate collect from the site. But it requires very strict inclusion of the sample. And if any of you feel interest about drug test with the Vivax, then we can discuss later. And yes, and in conclusion, then with the Plasmodium and parasite test, we observed that it's still sensitive to current partner drugs like fitonidine, lumefantrine, and mefloquine. And we observed that integrating approach will provide a better understanding about drug resistance in both falciparum and Vivax. And actually, for integrating, there's a reason to integrating those methods because there's an association between the result of those two. And finally, I would like to thanks for mostly the collaboration and support from the Vietnam and NCD, and from the great support from GenRe-Mekong project and the site collaborators. And for the data, I would like also to thanks 4 people from my team. And also, lastly, I would like to send a big thanks for the funder, especially the Bill and Melinda Gates Foundation and the Global Fund to support us the grant to conduct the study. Thank you very much.
Thank you, Nguyen, for that wonderful presentation. Questions? Yes, Tan.
Thank you, Dr. Nguyen. Very informative and great research. I got to have your comments. The first thing is, do you have any plan to do genetic surveillance for PM? Because some years ago, we don't think for PV, but suddenly PV increased. And also now with PM, very few, but now also increase sometime 50, 60% is hotspot. Yes, this is the first question. The second, do you think that chloroquine sensitive with PV, or PV sensitive to all kind of drug? You saw the Earth research. So do you think in Vietnam we don't need to use 2 points like chloroquine and ACT for treatment malaria, that take 1 ACT to treat both PF and PV? What do you think? How do you think? Thank you.
Thank you, Dr. Tang, for the question. For the first question related to Plasmodium malaria, actually we are conducting the genetic surveillance for PM, especially to respond for the information from the recent outbreak of recent increasing of the case in Thanh Hoa recently. We do collect the sample and it is still in analyze. And it is for genetics. For in vitro, we have no experience working with the malaria in vitro, to tell the truth. For the second question, actually, one of our previous publication to comparing the treatment efficacy between chloroquine and ACT in Vietnam has shown that both chloroquine and ACT has the comparable efficacy in treatment of Vivax. It means the treatment successful rate is really high. And learning from the data from in vitro, I think several samples can give us some early introduction about the drug resistance, but we need to investigate more to understand about the current vivax parasite population in the country, and if the upcoming data show the parasite still sensitive to chloroquine and other drugs, I would suggest that the NFCP to consider between the parasite, both vivax and parasite will circulate the same in any area, and it is the drug exposure. One patient can be infected of both species, so it's not easy to suggest that using only one ACT for treatment all of the species, but we need to think about the exposure of the drug exposure of the parasite, including both principal and vivax. This is a difficult
Right.
question.
Yeah.
Yeah, thank you very much for a good informative presentation. I just would like to know that you have been shown that chloroquine has been resistant with all drugs. But specifically, I want to ask about chloroquine, and you also that for PF already resistant for that. Do the research of mutation can tell us that it's the proportion or powerful of the resistance, and what I mean it's something like you need to change now, or you can still use because the resistance still 10%, 20%. Do your ability to tell us that is one question. And the second question is, you know that do you have ability to combine, because you have data of the artemisinin resistant and you have a single drug resistant, but we are UACT. So do you have ability to combine that your ACT is also alerted for resistance? Yeah, because you are, but I know that very a little bit difficult, but just want to know what I'm saying, and also want to ask the previous question, one more question, because I had no chance to ask. We have at least we want to know the status or alert or resistant to particular drug, in terms of, because I know that you need to pull sample, you wait from sample to do something, because very expensive while you are do one thing, just a small sample. So it will take time, 3 months or something. Do you know that you know that currently there is an outbreak in Thailand and Myanmar border? These is the way that you need to looking at, and not waiting in order to alert in the Mekong country that your ACT or the resistant or something like that. So because let every program to know that this is outbreak where the combination with mobile migrant and also combination with the resistant, because this is very important. So I just want to let you already know that the situation in the region. So you have to pick some sample in the particular outbreak of the country and to analyze so quickly to provide some result to the country, in order to make sure that we can know in advance, rather than, because one of your sentence is say that detect resistance before begin clinical evidence, but in order to do that, you need to do what I'm suggesting. Thank you.
Oh, that's a lot of questions. Sorry, if I could just address, start from your last point. We have had some experience at sort of rapidly responding to an outbreak in Laos. And that worked best because it was very much driven. Dr. Keo just comes in right now. It was very much driven by Simpe in Laos, and they, I mean, a lot of how fast we respond really depends on how rapidly the samples can be collected, how rapidly can be sent through, and so on. So, and we hope that we can get the same sort of degree of urgency, for example, on the tiny and marble and so on. So I think we are learning how to respond in that way. So that's one thing. Yeah, another question you had was about combining drugs. So when we do genetic predictions, we look at the drugs separately and basically make a prediction by saying that if you're resistant to both, then you're resistant to the combination. Now, does that correspond exactly to the clinical phenotype? It's very, very hard to predict because in clinical phenotypes, you have the problem that actually you don't know how the individual drugs are behaving. And you may think everything is working until everything is failing, you know, and that's a tricky situation. Would you like to add something, Nguyen?
I think for actually currently combination use is combination between artemisinin and the other partner drugs, and I think the GenRe-Mekong also do prediction the resistance to the combination. Not only the resistance to each drug, but also we do the prediction of the combination based on the genetics data. And in solid specifics and about the chloroquine.
My question is because I'm worried in the situation in Vietnam. Currently, the proportion of PF in Vietnam also has some proportion on that, not like Cambodia. Cambodia PF only 3%, Vivac in 97%. So I'm not the case because currently we are talking about MDA or chloroquine for target Vivac. But when you do it, it's not only Vivac, will be falciparum there. Yeah, when you do MDA, every patient will be including PF, including PV there. For Cambodia, I'm not worried. But I'm worried in when we are MDA chloroquine for target Vivac in Vietnam. But you also will be target PF as well because PF is down around. So with the chloroquine, they have already resistant with PF malaria in Vietnam, also in GMS. So that's why I want to know that how far that we still can survive for this NDA for chloroquine for PF. Yeah, you do for PV, but actually MDA don't tell you the is PV or PF because the subclinical there or something that. So just want to know that does the genetic can predict that you can do MDA only last if your target is PF, you can do only 2 years more, cannot do more than that. The prediction of something, I don't know.
From my understanding that the area that Vietnam and NCP target to do MDA with chloroquine is the area we only detect of Vivax for several years and no falciparum was detected there. So that's why there's less concern about the exposure of chloroquine resistant Plasmodium falciparum there.